Alright guys, welcome back guys. This is the third video of this lesson 7.1. We in this video we are gonna go example how to construct these confidence interval and interpret the result and see what it's actually is saying. And then after that I'll show you guys the calculator approach to get the answer as well. So just to continue from the last video, we took a sidetrack a little bit to discuss the concept of what does it mean to say that we're this person's confidence and such, and kind of looking at that through a visual perspective. So to continue where we left off there, the next definition we have here is called, well, let's start with that one there. So they're saying the maximum likely difference between the observed sample proportion p hat and the true value of the population proportion p. This is called the margin of error. So this is saying that if our estimate is p hat and p is the the actual value of the parameter, then if we take the difference between them, p hat and p, we look at the difference between them. It could be on the left sides of p or to the right side of p, so that could be the absolute value. So this is called the margin of error. Okay, meaning how far off is the estimate. How far off is the estimate? Okay. All right. So in term notation, we denote that margin of error. We say that E denotes the maximum error of the estimate and can be found by multiplying the critical value and the standard deviation of the sample proportion, that is. So this requires to introduce a distribution of sample proportion, so the distribution of p hat. Okay, so the standard deviation sigma of p hat is this here. So this is the square root of p hat times 1 minus p hat over n. So in the sample distribution of sample means, we did all that work. We didn't quite go over the distribution of the sample proportion, but it's very similar. We have the standard deviation of p hat or the mean of all p hat and all that stuff, and we have similar result to the distribution of sample means. Anyway, so E is the maximum error or the margin of error. This denote the error of the estimate, and this is equal to z alpha over 2 times the square root of square root of p hat times 1 minus p hat over n. So this here, we learned that from previous chapters. So that is the critical value. And then this there is a sigma of p hat, which is the standard deviation of sample proportion. So that right there is the margin of error. And then alpha, we didn't quite discuss alpha much up to this point, but pretty much what alpha stands for is the level of significant, meaning where is that cutoff value between the critical value is the point that separate values, data values that significant versus non-significant. So alpha kind of act the percentage, the probability, or the area where we're looking at what will be that significant level there. So that's what alpha stands for. And to get alpha, we take 1, which is 100% under the curve, minus the confidence level. Next, to put everything together to get the confidence interval, first we need to know what p hat is, and p hat is usually come from the sample data. And then if we take p hat, subtract margin of error, then what we can say in that the actual value of p is between those two endpoints, p hat plus e here. Okay, so this can be thought as p hat minus e comma p hat plus e. So either notation will be fine. So both are the same things. So this is a confidence interval. Okay, so this consists all the values between p hat minus e and p p hat plus e, so the p-value could be innate. What confidence level we think that p is innate? 90%, 95%, so whatever we're looking at. So that's usually given first, and then we go ahead and find e, and then from there we just add and subtract from the p hat. So as far as the math go, that is pretty straightforward. As far as the concept go, where this formula come from, how do we get all this stuff, it does take up another video to explain all that stuff. But I'm gonna try not to confuse you too much. I'm just gonna go straight to the example. I think I've done enough confusing with all the concept already from the beginning here. So formula wise, this is how we get the confidence interval. We start with the confidence level. We get the alpha after that, and from alpha we can get the critical value, and then it times up to the standard deviations of the sample portions that give us the margin of error, the maximum likely difference of error, and then from there we just add and subtract the sample portion to get the interval itself. Okay, and then from there we can go ahead and interpret what that interval is saying. So let's jump into an example here. Using the same example early on, still looking at the sample size, 1487 adults were surveyed, and 966 of them said they have a Facebook page, obtaining a point estimate for the proportion of all adults who have a Facebook page. So that was the example at the beginning of this lesson here. So now we are going to estimate this here by using confidence interval. Okay, so our point estimate was I think it was 0.65, I believe. So now we are going to use a range of values, a confidence interval, to estimate the actual proportion of all adults who have a Facebook page. Okay, so here are some of the steps here. So the very first thing you want to look at is the sample size, 1487. The next thing is, what is the X value in this case? That's the number of adults say that they have a Facebook page from the sample of 1487. And then from there, you calculate your point estimate or your sample portion. And I believe that was around 65%. The next thing you want to do is you want to look at alpha. What is the significant level? And that is taking 1 minus the level of confidence, which is 0.9. That will give you 0.1. So 90 level of confidence is 0.9. So that's this right here. Okay. So the next thing is figure out alpha over 2. And that is just 0.1 divided by 2, which is 0.05, 5%. Then you want to look at the critical value. So the critical value is z sub alpha over 2, and that's equivalent to z sub 0.05. And if you use the z table, you look this up, and that's come out to be 1.65. Okay, so that's the first thing you do. All those things. List out all those information. The second thing is find the margin of error. Okay, so that's going to be E. So E is equal to the critical value times the standard deviation of all the sample proportions. So that is P hat times 1 minus P hat over N. So Z of alpha over 2, that is 1.65 times P hat is 0.65. 1 minus P hat is 0.35 over sample size 1487. We're going to use a calculator to get the answer. So that's going to come out to be roughly 0.02. So that's the maximum difference, is about 2%. We allow or estimate to be about 2% to the right, 2% to the left from our P hat. So now put all this together. So the third step is we're going to say our 90% confidence interval is now P hat minus E, P hat plus E. That's the same thing as 0.65 minus 0.02, 0.65 plus 0.02. And so that's going to become, I'm running out of room here, so I might just going to go up there. It's going to be, let's use purple. It's going to be between 0.63 to 0.67. So that's our 90% confidence interval. Okay. So the interpretation of this would be, so how do we interpret this interval? So we're saying that we are, so this is the correct way of saying that we are 90% confident that the true value P, and P stand for all adults who have a Facebook page. So the actual portion, the actual true value of all adults who have a Facebook page is between 63% to 67%. Okay, so this is a much better a way of estimate what is the actual true value of P, and how confident are we with this estimate. We're about 90% confidence, and again, the 90% confidence means from the previous video, the confidence come from the fact that, one second, let me erase this here. The confidence come from the fact that, if we were to sample more different groups of 1487 adults, 90% of those interval will capture the actual value P. Okay, so let me write that out for us here. So this means, if we select many more different sample of size 1487 and construct the corresponding intervals, then we're going to find out that 90% of those interval would likely to contain the value P. And we've seen that demonstration through this diagram here, a little bit of that. Okay, so that's I'm trying not to dig into too much of that to confuse more, but this is how we write the correct interpretation. Okay, and then this is how we understand. This is how we sort of understand what the 90% confidence level means. Okay. Right. So that's the long way of calculating the confidence interval by going through all those steps. Okay, so this is kind of work that I expect you guys to show if we would do this on a quiz exam. Here is the much quicker way to do this without going through all these steps here, and then this might help you on the homework, so that way you don't have to spend a lot of time doing 10 problems in a row doing the long way. So I'm going to show you guys doing this, getting the same confidence interval using the calculator approach. Okay, so keep in mind this is our answer here. So let's go to your calculator. All right, so what we want to do is we want to click on the stats button. Okay, and then we're going to go over to the tests, and then we're going to go down to select option where it said option A, 1 proportion to the interval. Okay, click on that, and then I want to clear this. How do I do clear this first? Clear, delete. So it doesn't have an option for me to clear the whole thing. So let's do that. Let's exit out. Let's try that again. Test. Okay, so anyway, so I can't clear this. So on your calculator, it's going to be a little bit different. But to get there is the same thing. What you want to do is you want to type in the X. That was 966 of adults who said they have a Facebook. And then you're going to go down to the N, which is sample size 1487. And then you're going to type in the confidence level, which is given in this case is 90%. And so once you enter all the information, you click enter or calculate. Okay, and mine doesn't get. Let's try that again. portion Z interval, enter, done. So it doesn't show up on this screen here. So what I guess for this calculator I'm using here, it show up here on the right side there. So we're looking at lower, upper, and then p hat. So what that's the what we're gonna use that there. Let me just screenshot this, and then do that to Knowability, and then add to that, import. So on your calculator, it's gonna be slightly different. On this calculator here, you know, well, you still need to put the you know, the nx, the x, and then the n, and the confidence interval, and then when you hit calculate, you know, it'll give you this here. So what that means is, or 90% confidence interval now is going to be from 0.629 to 0.669, and that's going to be the answer there. So this is what this takes about a few buttons click here to get the answer. So it's going to help you a lot on some of the problems to check your work, whether you should get the correct answer or not. But this is what we're looking at in terms of the work here. Is going to go through these steps here. Okay.